Welcome from Maths and Science channel. Now, in this new video, we are bringing a new concept wherein how to plot the exponential graphs. In the previous videos, we have learnt simple methods. Now in this video, we will be learning a new method of plotting which will be useful for Maths Olympiad examinations and also IIT JEE and other mathematics competitive examinations. You just see the equation what we have to solve is 3 to the power of 4x plus 4 to the power of 3y is equal to 5 to the power of x plus y. It's a very complicated equation. It's not that simple to solve it, and we'll try to get the approximate solution. Without a calculator, and at the same time we'll try to plot the curve. The approach for plotting will be totally different. A different approach we'll adopt. A new approach, a different approach. Now, let us try to understand the question. Let's go further. The question is 3 to the power of 4x plus 4 to the power of 3y is equal to 5 to the power of x plus y to be solved and to be plotted. This is what is the question. Solve and plot. 3 to the power of 4x plus 4 to the power of 3y is equal to 5 to the power of x plus y. As a simple measure, we will start step 1. Let us say x is equal to 0, y is equal to 0. Does it give any solution? Let us see. 3 to the power of 4 into 0 plus 4 to the power of 3 into 0 is equal to left hand side. That is equal to 1 plus 1, that is equal to 2. What is the right hand side? 5 to the power of 0 plus 0, that is equal to 1. Left hand side is equal to 2 is not equal to right hand side. It's not equal to right hand side. It's not equal to right hand side. Right hand side is equal to 1. Both are not equal. Here, left hand side is equal to 2, right hand side is equal to 1. Implies left hand side is not equal to right hand side. That means x is equal to 0, y is equal to 0 is not a solution. This curve doesn't go through origin. Next, step 2. If x is greater than 0 and y is greater than 0, what happens? Please listen to it carefully. This is what is the approach we are doing it for plotting it and solving it. We are not directly able to solve it because it's a complex equation. It's a complicated equation. If x is greater than 0, what happens? 3 to the power of 4 to the power of x. 3 to the power of 4x is equal to 3 to the power of 4 to the power of x, and 4 to the power of 3y is equal to 4 cube to the power of y, and 5 to the power of x plus y is same as 5 to the power of x plus y. You just see. 3 to the power of 4x is equal to 3 to the power of 4 is 3 into 3 9, 9 into 3 27, 27 into 3 81. 81 to the power of x. 4 to the power of 3y is equal to 4 4 ja 16, 16 4 ja 64, 64 to the power of y, 5 to the power of x plus y. These are the parameters given, the elements given in the equation. Can we write the given question as 81 to the power of x plus 64 to the power of y is equal to 5 to the power of x plus y? If x is greater than 0 and y is greater than 0, for any small value of x and y, for any small value of x and y, please try to understand the logic. For any small value of x and y, however small may be, however big may be, 81 to the power of x plus 64 to the power of y cannot be equal to 5 to the power of x plus y. Take this graph, 4 quadrant, let us say. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. If I talk about the first quadrant, if x is equal to positive, 0 is ruled out, x is equal to 0, y is equal to 0, that solution is ruled out. It is not passing through the origin. Let us find out if this curve is passing through first quadrant. If it has to pass through first quadrant, means a curve, it can take any shape depending upon the equation. X is positive. What is the first quadrant? X is equal to positive, y is equal to positive. That means x is greater than 0, y is greater than 0. If x is equal to greater than 0 and y is equal to greater than 0, then let us try to find out, is there any point on the curve which is in the first quadrant? Is there any point on the curve which is in first quadrant? From the normal understanding, 81 is greater than 5. Please see, 81 is greater than 5. 64 is greater than 5. 81 to the power of x will be greater than 5 to the power of x. 64 to the power of y will be greater than 5 to the power of y. And what is 5 to the power of x plus y? 5 to the power of x into 5 to the power of y. Means 5 to the power of x plus y is always less than 81 to the power of x into 64 to the power of y. When you multiply these two, 81 to the power of x into 64 to the power of y, 5 to the power of x plus y is always lesser than 81 to the power of x into 64 to the power of y. And for example, let us say left hand side is equal to 81 to the power of x plus 64 to the power of y. If x is greater than 0, y is greater than 0, let us say some 1000, let us say some 10,000, any value greater than 0. 81 to the power of 100, let us say, plus 64 to the power of 100. Can it be equal to 5 to the power of 100? 100 plus 100. Five to the power of 200. Whenever you multiply 5 with 5, it should have a value, the last digit should be either 5 or 0. Here, when you multiply 81, the last digit is 1, and when you multiply 64, the last digit is 6 or 4. Can we say at any point of time 81 to the power of 100, 64 to the power of 100 will be equal to 5 to the power of 200? Or for that matter, for any value, it's not possible. That means this curve cannot lie in the first quadrant. Now let us say second quadrant. Let us take second quadrant. X is less than 0, y is greater than 0. Then 81 to the power of some minus value, negative value, plus 64 to the power of some positive value is equal to 5 to the power of either positive or negative. Will it be possible? 81, when it is divided, when x is less than 0, this 81 will be divided. It will be a fraction. This fraction added to a bigger value, 64 to the positive power, can it be equal to the 5 to the power of bigger value? It is also not possible. What a possible solution we can think? The possible solution we can think in real numbers, I am talking about only real numbers. Real numbers is 83rd quadrant. Let us examine. 81 to the power of minus some minus plus 64 to the power of some minus is going to give you 5 to the power of some minus. Plus values it could not give. Let us see whether minus values can it give. For example, here let us say I have taken x is equal to half, y is equal to half, minus half, minus half in the third quadrant. It implies 81 to the power of minus half, 64 to the power of minus half. Then third value will be, right hand side will be 5 to the power of minus half plus minus half. That is equal to 5 to the power of minus 1. What is the 5 to the power of minus 1 is? 1 by 5. That is 0.20. Can this point lie on the curve? X is equal to minus half and y is equal to minus half. Can this lie on the curve? Let us see. 81 to the power of minus half plus 64 to the power of minus half, that is left hand side, that is equal to 81. For example, if I approximate this value to the power of square root, 1 by square root of 81 plus 1 by square root of 64. 81 square root we can approximate. Let us take an approximate value. If I approximate, what happens? Square root of 81. If I approximate, square root of 81 will be 9, 1 by 9, 64 will be 1 by 8. That means left hand side is equal to 17 by 72. That is approximately 17 3 ja, 17 4 ja 68, 17 4.3, 1 by 4.3. Here it is 1 by 5. Just see. That means it is almost, left hand side is almost matching with right hand side. That means there is a point having minus powers in the range in and around minus half. That is an approximate solution. If you want to practically check for these other numbers also, you can put 1, 2, 3 and see exponentially they are going up, the positive values. And one positive, one negative also of no use. Both should be negative. Then only we can have this curve. Now, we can further approximate it. Can we do it? Let us go for 81 to the power of minus 1 by 3 plus 64 to the power of minus 1 by 3 is equal to left hand side. Then what is left hand side? 81 to the power of minus 1 by 3 is 1 by 81 cubed root plus 1 by 64 cubed root. Cubed root of 81 is, you can take approximate value Just see. If you take some value here for square root 9, cubed root we can take 5 into 5 into 5, 125, 4 into 4 into 4, 64. That means 5 and 4 in between. We can take a value between 5 and 4 for cubed root of 81. Can we approximate it to 1 by 4.3 and cubed root of 64? It is a tedious example, but however I have taken it. When we solve tedious examples only, we will be able to solve very easily the questions there. This will be 4. Then you just see 4.3 into 4 is approximately 17.2, 4 plus 4.3, 8.3, 8.3 divided by left hand side is equal to 8.3 divided by 17.2 and right hand side is equal to 5 to the power of minus 1 by 3 minus 1 by 3, 5 to the power of minus 2 by 3, 1 by 5 to the power of 2 by 3. What is 5 to the power of 1 by 3? Just see. What best can we get the answer? One by 2.9. This will be 8.3 by 17.2. That is approximately, I can say it will be 0.5, and this is approximately around 0.35. And this 0.5 and 0.35, they are not equal. Left hand side is not equal to right hand side when value becomes 1 by 3, minus 1 by 3. When value becomes approximately minus half, it is not fully tallying, but it is little bit okay, it's not bad. Now, we can say the change as minus 1 by 3 and minus 1 by 2, when you compare, the difference between the left hand side and right hand side is smaller in the previous case. That can we say roughly in that case that at x is equal to minus 0.6 and y is equal to minus 0.6, can we say left hand side is equal to right hand side? Approximately. The error may be little bit less. That means the approximate solution is coming like this. Let us draw the graph now. A different approach in this problem. It's not a regular approach. First quadrant, second quadrant, we have eliminated. In which the curve lies, that quadrant we have caught hold of. Now we got a point. It is approximate. We got a point here that's lying on the curve, and when it is minus half, then when it is minus half like this, it's not lying on the curve, and when it is more than minus 0.6, it is lying on the curve, and the curve can be of this shape. This is the shape of the curve. Further, we can analyze for different values, and we can draw the perfect curve with the help of numerical analysis. That's one of the major engineering or mathematical revolution. This type of problems where you cannot get the analytical solution, we tried to get the analytical solution, we are unable to get the analytical solution, then we will go for numerical methods. Those numerical methods we will be applying as we proceed further in understanding these questions. Why I am taking up the toughest algebraic equations, exponential equations? The reason being, the more tough you practice, the more ease with which you can answer the questions in the examination. Practicing should be the place where you throw the challenge and try to solve it and get something out of it, and you will get some knowledge out of it, additional knowledge, which you will employ, if not in the direct same questions, in any other question also you try to employ these methods, this additional knowledge in the examination and solve the question, because we cannot predict the questions in the Maths Olympiad. It's an international examination, we cannot predict. We cannot predict the type of the examinations and also the type of the questions they being asked. We should be ready for all types of questions. Best of luck to everybody. Thank you for listening to me. I am from Science and Maths and Science channel. Maths and Science channel. My channel is Maths and Science channel. If you feel you have got some value addition to your knowledge, please subscribe to my channel and view, review and comment on my videos. Till now, many videos are released from this channel for Maths Olympiad and also IIT JEE examinations. Very good competitive examinations in mathematics. The question may not be solving type. A question can be of plotting of the graph by giving a particular equation. Without using the calculator, you have to visualize and draw the graph shape. You need not get the exact values, at least you can remember the shape of the curve. Best of luck. Thank you for listening to me. Thank you for viewing my video.